Group 61, and our presentation is on terminal velocity and how it varies for different sized objects. And one situation that we looked at was the difference in terminal velocity for an adult versus a child in free fall. And this video, we're not going to play, but it shows these skydivers in free fall and gives a summary of the principles of terminal velocity. And we hypothesized from these observations that the terminal velocity of a child would be the same as that of an adult in free fall. And we came to this hypothesis by thinking that the only difference would be in the drag coefficient, and it would be small enough that its effect on terminal velocity would be negligible, so they would be the same.
So the force acting on the person while free falling are just two forces: drag force and gravitational force that's pulling the person downward. By looking at the drag force equation, it's density times velocity squared times drag coefficient, which for some shapes can change with the Reynolds number and the roughness of the surfaces, times area divided by 2. The force acting downwards is simply just mass times acceleration, which is 9.8 meters second squared. In order to calculate the terminal velocity v, we have to put two equations together and make it 0, which means the summation of y-axis forces has to be 0.
So for the analysis of adult, our assumption for the mass of adult is around 80 kilograms and the surface area is 0.38 meters squared. So we know that the density of air is 1.225 kilogram per meter cube and the coefficient of drag is 1.2. So by using the drag formula, we can find the terminal velocity, and for adult it's about 53.01 meter per second.
For this case, we're going to assume the mass of child is 32 kilogram, and then the surface area is going to be 0.16 meter square, and then we know the density of air is 1.225 kilogram per meter cube, and we're going to use coefficient drag is 1, and then from the drag force formula we could find the terminal velocity, and the terminal velocity of a child is going to be 56.59 meter per second.
So in conclusion, what we found out was our hypothesis was actually incorrect. However, we learned on the way that the reason it was incorrect was because in non-ideal systems, terminal velocities are very similar, however not the same. And this is because the only different variable in the equation happens to be area of the object falling as well as the coefficient of drag. It is important to note that the coefficient of drag that we decided on for each situation was due to different objects we found after researching what the coefficient of drag was, and we decided on the values as before. And that's terminal velocity.